this video we're going to be looking at a distance rate time problem. And so Marion drove to a resort 335 miles from her home. She averaged 60 miles per hour for the first part of her trip and 55 miles per hour for the second part. So that's two parts of the drive, one at a faster speed and one at a slower speed. If her total driving time was 5 3/4 hours, how long did she travel at each rate? And remember the 4 steps that I have to solve an application problem like this: define the variables, set up the system, solve the system, and state your answer. So we're going to start by defining the variables, and it's very important here not to get lazy with this, but to write it out every time. It's going to help you to organize your thoughts, and it's going to give you a nice starting point. So I always look at the last sentence to figure out what is the problem asking me to do. And it says, how long did she travel at each rate? Remember, there were 2 rates. And so this would be a length of time, how long. And so we're looking for 2 different times, the time traveled at 60 miles per hour and the time traveled at 55. And so I'm going to set up my 2 variables that way. Now we could use x and y, and some people do. I'm going to choose to use a variable that helps me to separate the 2. Like, I'm going to use the letter f for the first part and the letter s for the second part. It just helps me in my mind to keep the 2 variables separate. So f is time for first part, and s is time for second part. And remember, you could use x and y or any other combination of variables that you choose. Okay, so then you guys know the formula distance equals rate times time. We have worked with that formula now a couple of times, I believe, in this semester. And so we're going to set up a table to kind of organize our thoughts on this. What I ultimately need to do is set up a system of equations. But there's so much information and there's different ways of combining these things. I'm just going to set up a table, organize thoughts, and then we'll proceed from there. So the first thing I'm going to do is I'm going to make each row a different part of the trip. So the first part and the second part. And then the columns are going to be the distance, rate, and time. Actually, I'm going to reverse that order. We're going to start with the rate multiplied by the time equal to the distance. Extend those over. Okay, and now in each column then I'm going to put the appropriate either variable or number. So for instance, the rate for the first part of the trip was 60 miles per hour. The rate for the second part of the trip was 55. The time for the first part of the trip was f, and the time for the second part was s. Those are the 2 numbers we don't know. Move this up a little. The distance, we know, is the product of the rate and time. So distance should, for the first part, be 60f, and for the second part be 55s. Okay? And so if I want to construct a couple of equations, I need to use these 2 totals that are in the problem, the 5 3/4 hours and the 335 miles. The 2 times added together should equal my total driving time, or her total driving time. Okay, so the first equation I'm going to use is the sum of f and s, that's the 2 times, equaling the total time it took, 5 3/4 hours. The second equation is going to be the sum of the 2 distances, equaling the total distance driven. Okay, so that would be 60f plus 55s equals 335. Okay, And so those two equations make up my system. Now, I could solve this either with substitution or addition. I'm going to choose substitution because it's really easy to solve for a variable up here in this first equation. I'm going to solve for f. To do that, I'm going to subtract an s from both sides of this equation. And remember that the fraction there and the s are unlike terms, so I cannot combine them. So I'm going to get f equals 5 3/4 minus s. And then I'm going to take that new expression and plug it in for the f in the other equation. That's our substitution step. Alright, and so I'm going to rewrite this out as 60 times that new expression plus 55s equals 335. And in those parentheses, I'm going to write 5 3/4 minus s. Alright, now I've got a little bit of arithmetic to do. I've got to distribute the 60, and when I do 60 times 5 3/4, I'm going to take that off to the side for a moment to actually work that out. So I'm going to take 60 multiplied by, now 5 3/4, if I want to write that as an improper fraction, which I should do for multiplication, 5 times 4 is 20 plus 3 is 23/4. And the 60, while I'm at it, I might as well write it with a 1 denominator. Now, if you notice, before I multiply, 60 and 4 share a common factor of 4. So if I divide them both by 4, 60 becomes 15 and 4 becomes 1. And so really all I need to do is multiply 15 times 23 to get that answer. And that's going to be 5 times 3 is 15, 10, 11, 0, and then 1 times 3 and 1 times 2. Add those up. Should be 345. So 60 times 5 3/4 is 345. 60 times s is 60s. Then I get 55s and 335. I'm going to combine my like terms. 345, negative 60 plus 55 is going to be a minus 5s. I'm going to subtract 345 from both sides. So negative 5s equals, this is negative 10. And I'm going to divide by the minus 5. And so s is equal to 2. Okay. Alright, so now if s is equal to 2, that's the number of hours spent traveling at the second speed. I need to find the number of hours spent traveling at the first speed. And so to do that, I'm going to use f. I'm going to use this equation up here. I'm going to take that 2 off of the 5 3/4. So 5 3/4 minus the s, which is now 2. And of course, 5 3/4 minus 2 is 3 3/4. And so I should have my 2, whoops, can't see that. I should have my 2 times, so 5 3/4 minus 2 is 3 3/4. And that comes from this 2, the s becoming 2. And then I can just simply write out my answer. So I've already solved the system. Now I got to state my final answer. And I'll do that way down here at the bottom. I'll say Marion drove 2 hours at 55 miles per hour and 3 3/4 hours at 60. I'll do mph, there we go, miles per hour. Okay, that gives me a good solution, final solution.